when other messages come through. So let's have a look at how this works. So I'm just going to run the server from the command line, and it doesn't say anything because there was nothing to say. Now, I've recently started using Terminator as my Linux-based terminal client, and it's kind of cool because you can have lots of little windows and you can even drag them around, but I'm not going to do that this time. But I just wanted to show you. So let's imagine that the red highlight is the current window I'm looking at. So let's imagine this is chat person 1 and this one over here is chat person 2. So I'm going to telnet to localhost on port 8080. I'm not going to make any HTTP requests at the moment because if you remember from the chat system, we weren't actually talking in HTTP, we were just sending raw messages from one client to another client. So this is pure text-based over port 8080. Going to log in, and we can see down at the bottom here somebody connected. If I jump over to this side here and log in again, you can see somebody else connected. The message appears almost instantaneously in user 2's window. We've got a log here saying sending message, I am user 1. And if I then disconnect, just to prove it works both directions, if I then disconnect from this side here, we see that somebody disconnected. And if I send a message over here, you see there's no error because we're not trying to send to a connection that doesn't exist. So it takes the awesomeness of React, much easier to see what you're doing. If you compare with the original code that I was looking at, the curl one I think is probably the easiest way of doing it in the old style, where you get a known system that has robustness to make an HTTP request to a remote process, and that process that can then ensure that it runs no matter what happens to the original requester. It's probably the cleanest way of doing it. The detachment method, the second one I showed, means you've got all the code in one place, but it's not reliable. So this takes the awesomeness, or React takes the awesomeness of that. All your code is in one place, and you've got the clean object-oriented model of development. But it also uses the best of all of the old worlds of communication. And it adds WebSockets on top through Ratchet. So the React doesn't actually support the WebSockets, it's the Ratchet set of the Ratchet framework that sits on top of it that provides those. But you still face the same issues, memory overflow. I could do that in Ratchet as well. So where to from here? The loop itself, essentially because PHP isn't threaded or any of those things, it's actually still running a loop. It's just an event-based loop, and because it's not going through, because it's running within its own server, not through something like Apache, it's able to break out those events more easily, but it's still very slow because it's still processing it in a very procedural manner. So if you use something like libevent, which is a Linux-based library, it's external of PHP and Apache and all those things. If you install that, Ratchet will actually pick up the fact that it's installed automatically, and it'll stop using the PHP loop and start using libevent, which will increase the speed at which it's able to handle events significantly. When you deploy, one of the major issues with deployment is the fact that it is running on its own port. So you need to work out things like load balancing. What some people do is stick Varnish in front of it, and then depending on the kind of request that comes in, they would still all come in on port 80 or 443. Depending on the kind of request that comes in, which Varnish can detect, it'll either send it off to Apache Nginx, IIS, whatever you're using for your web serving, or to port 8080 or whatever you're running your React system on. And to solve the problem of the PHP process dying, there's a tool, there's a number of different tools, but the most prominent one is Supervisor D, the D being for daemon, which is the suffix in most Linux space applications to say I'm running in the background and I'm doing a tool, like a web server, for example. So it's basically a supervisor to make sure that your daemons are still running. So if you configure Supervisor D to make sure that React is running, then if React dies, it can spawn it straight up again. So you've still got that little bit of downtime, but it should be unnoticeable to most clients using the web service. Mathematics. So it's 35 past. I believe I have 10 minutes, so I can do some demos. Does anybody have any questions about what I've done so far? I can go back and do demos of the previous way that it used to be done, just to show the logging. Yes?
Does this approach introduce any challenges in terms of debugging? I know that switching over to some event loop systems, you end up with crash dumps that are impossible to
Sure.
make sense of.
So, so the question was, does it make it harder to debug when you're using this kind of a system? The problem with asynchronous development is that it happens in a time that is not equal to the time that you're monitoring it in terms of application debugging tools. You get the same issue when you use things like SOAP between remote systems, because there's a transaction bit in the middle and a translation process that happens somewhere. So it's always harder to debug when you can't actually step through the code as it's supposed to be running. The best advice that I have from experience with working with event-based triggers is just to do lots of logging. So you would have an event log somewhere that you are able to output object level dumps of information if you need to, or just line items in the way that the somebody connected, somebody disconnected happened, in order to be able to isolate the area they're working on. Personally, I haven't found any great tools for debugging in PHP land event-based systems. Has anybody else here found any that work? Event-based debugging systems for event-based programming in PHP? No. I think it's one of those things that's the next hard problem to solve in event-based programming. Anybody else?
The initial example you gave with the taking an order, you've shown basically you make a request to the payment gateway, and while you're waiting for that request to come back,
Yep.
you're doing something else. So essentially you need to get the result back. So using curl or any of the other examples, you're just sort of making a call and then your script's terminating, whereas what you need is to go off and do something else and then collect the output, maybe update the order with a success or failed,
Yep.
and handle appropriately. Is React going to handle that sort of scenario as well, where you can truly be async?
Sure.
You're just offloading.
So the question was around this authorized payment part. You send off the request, you need some way of being able to collect the response again at the other end in event-based programming. So typically what you'd have is something like a callback. Does React support callbacks from remote systems for standard HTTP requests that's sent off? So imagine, say for example, and I'll pick on one of our sponsors, you're using the Braintree integration and you send a request off to Braintree, his head just perked up. You send a request off to Braintree, you've got to wait for that response to come back, but it's still a single HTTP request. And is React asynchronous enough to be able to background that and then get the information back? What I would do in React, and I don't believe there's a way of, unless you have any level of control over the remote system that's able to then formulate a response back, if you can tell it to call back, then no, because you don't have control over that system. And in the case where you don't have that, which is a fairly likely example, what I would do at this point here is I would send this whole process into the background somewhere. And I might then merge something like React with shell exec, where I would say in the background, run a PHP process that sends this request off to Braintree, and then when it gets a result, put it into this log file, and then within the React system. So the example I showed was with the loop function. There's also a timer function, so you can have every 5 seconds run this function. And every 5 seconds you would just say, has this log file changed?